Hello everyone, I am DEVANK JAIN, pursuing my civil engineering from Skyfi Jaipur. Today we will be designing a building as a part of final assessment of tall building design course on the Skyfi Lab. The problem you can see here. This is a 23-story building in which the lateral section of the building is different for different section. As you can see, story 1 to 8 have different certain parameters. That is, dead load is of 2, live load is of 5 kN per meter square. And then we see further 9 to 14, dead load is same, but again live load is differ from the previous one, that is 4.5. 15 to 19, live load is of 4. Then last section, story 20 to 23, that is live load of 3.5. In this we have given the dimensions of beams and columns, that is 500 by 500, 550 and by 550, 600 by 600, all dimensions are in mm, and same for beams. And the materials is of M40, and rebar material is HYSD 500 and mild 250, and the slab which will be used is of thickness 150 mm and M40 grade of concrete. And we will use the outer cladding, and the cladding load is of 0.2 kN per meter, and building is situated in Bangalore, and all the wind load will be considered according to the Bangalore. So we will start now. We will be opening ETABS 2016 software. From this we will design our tall building. This is the starting view. Click on new model. Click on use built-in settings with and display the unit in metric SI. Then click on the steel section database, which is according to Indian. Select the steel design code from the list bar is IS 800 2007, and same for concrete design code, selected from IS 456 2000. Click on OK. You will see a dialog box will appear in which we will see the grid lines. We have to set the number of grid lines and the spacing between them. Number of grid lines in x direction is of 4. Number of grid lines in y direction is also of 4. Spacing in x direction is will be of 6, and spacing in y direction is will be of 6. Then we come to the simple story data. In the number of stories will be 23, and the typical story height is of 23, and bottom story height is 3. As we have seen, there are different set of similar stories, so we have to customize the story data. Edit, then we click on custom story data, then edit story data. We will see the master story, story height, elevation, master story. Master story is the one which act as the parent story and remaining story will depend on its properties. So see, story 1 to 8 are of same set, so we set the story number 8 to master story. Click on yes, and then all stories below story 8 set them to yes. Sorry, and then similar, come to the similar part. Then story 8, story 7, click on story 8, similar to story 8, and click on story 8. Same thing for story 4, same thing for story 3, same thing for story this and this. Now then we will come to the story number 14, 9 to 14. We set as the story number 14 to be the master story. Click on yes, and all the stories similar to that of story 14, story 14, story 14, story 14. Then we will go further, and all the remaining story is same. Then 15 to 19, we set the 19th story as a master story, and then 18th is of similar to 19th is of 19th, 18th is of 19, and is of 19, and story 23 is already set to the master story, and story 22, 21 and 20 are all similar to story 23. Then click on OK and select grid line, grid only option from here, and then click on OK. You will be see these tabs will be opening, taking a little bit time. Here you can see it is looking like this. It is a plan view, it is a 3D view, and these all are the tabs and menu bar, toolbar. Here are the shortcut to draw column, beam, slab. We will use them. Now first of all, define material, which will be used here. So click on define material properties, add new material, set the region to be the India. Material type is first we will set a concrete. Standard is taken as Indian, and grade is we will use M40, and then click on OK. Nothing we will change here, and then click on OK, and again add new material. All set. Reason is same as India. Material will start using rebar, so the rebar is there, and grade we are using HYSD grade 500. Then click on OK, and again click on OK. Again add new material, same rebar, and grade now mild grade 250, and then click on OK, again OK. Now again click on OK after defining all the three materials you can see here, and then OK. Now we will define the frame sections, the column and beams and their dimensions. Then click on define section properties, frame section, and then you will see this dialog box will appear. Here click on add new property, select the sections shape concrete rectangular, concrete, and you will see this. Click on the property name as column 500 by 500. Select the material to be of M40 concrete grade, and the depth which is 500, and the width which is 500. Now we will modify the reinforcement in this column. Then click on modify show rebar. Select design type as PM to M3 design only. Rebar material longitudinal bars HYSD 500, select HYSD 500. Confinement bars, select mild 250, and then click on OK. Now all the things we have defined for this column, now click on OK. Now again, now you can see we will defining the same column but only having different in dimensions. So we are copying this property, add copy of property, only name we will change and their dimensions we will change. This 550 by 550 mm. Material is as before. The width we will change here 550 mm, and the depth is also 550 mm. You can see the in the modify reinforcement, you can see that all the properties we have selected is same as before. so we will change nothing here. Then click on OK. Again OK. You can see here a new column is defined here. Again add copy. Now the column is of 600 by 600, dimensions 600, width is also 600. Then click OK. All the three columns have been defined. Now we have to define the beam. So add new property, concrete rectangular, concrete. Name the section as beam 500 by 300. Select the material from the list bar menu as M40. Select the depth as 500 and width to be 300. Modify show rebar. Now see, now you select from the design type as M3 design only for beam, and the rebar material to be for longitudinal bars as HYSD 500 and for confinement bars as Mi250. Now the cover is of 25. Change it here and click on OK, and again click on OK. We'll do the same thing. Add copy of property. Name the section as. Now the dimensions are 550 by 350. So we'll change only then 550 by 350. Then click on OK. Again add copy, and now the dimensions are 600 by 400. Then click on OK. If you want to see reinforcement, you can see the same properties are selected. So click on OK and then OK. Now we have defined the beams and columns. Now we have to define auto select beam and auto select column, which the software will use according to it. So click on add new property, then concrete rectangular has a section shape, and then click on auto select list from here. Name it as column auto selection. Auto selection type is concrete. And from here to concrete, and then select only columns, and then click on add and click on OK. Now again for beams, auto select, auto selection, select from concrete, and then click on beam. All the three beams we have defined, and then click on add, click on OK. Now you can see all the beams and the beam auto selection, all the columns and the column auto selection have been defined. Now click on OK. Now we will define the slab thickness. So again go define and go for section properties and go for slab thickness. Now click on add new property, name it as slab 150. Select the slab material as M40 grade of concrete and thickness is 150 mm. Click on OK and now click on OK. Now come to the story 1, that is this, and select here two similar stories that a set of stories of 1 to 8. Now we will draw the columns for story 1 to 8. So select from drop view column brace object and select here quick draw columns. Here you will see the properties of object. So from the properties menu, click on column auto selection. Here you can see it, and all the make sure that you have selected the similar stories. Now select it from here and drag it and then release it. You can see in the 3D view only up to the 8th story the columns are placed. Now go to, you can select from here also. So click on quick draw beams columns. Select from here beam auto selection and then click on, drag it from here and then place it. You can see the beams are placed here. Now click on this up and down arrow to move to the story 9, which has a different set from story 1 to 8. So move to the story, that is story 9, and make sure that you have selected similar stories. Now again we will place the columns. Make sure the properties is of column auto selection, and we will place the columns only here and then here. Make sure that you have not selected this part and this part. Now click on quick draw beams for drawing the beams, beam auto selection, and draw the beams this way. You can see it in 3D view. Now we will move to the story number 15 to 19. That is a 50. So select quick draw column and you will place the columns over here and here. Save for beam. Now we'll move to the story number 20. And place the column over here only and beam over here only. Now you can see all the columns and beams have been placed according to different set of stories. Now again move to the story number 1. Now we will draw the slabs. So select quick draw floor wall option from here. Set the property as slab 150 which we have been defined and draw over the here. You can see all the slabs are placed and make sure the single stories have been selected. Now move to the story number 9 and place it here. Now move to the story number 50. Then move to the story number 20. Yes. Now all the columns and beams and slabs have been placed. Now we will define the dead loads and live loads. So we'll go to the story number 1 as before. First of all, make sure that you have selected the shells. So select the shells. You have selected all the shells. You can see it here, 168 shells. All the stories are selected. Then click on assign. Click on shell load. Click on uniform. Select the load pattern name as that. Click on uniform load 2. Click on apply and then click on OK. So you can see all the dead loads are applied to kilonewton per meter square. Now we will apply the live load, which is different for different set. So and again click on similar stories and make sure that you are at story 1 to 8. So make sure that you have selected the shells before applying the load. As a shell load, uniform, and then load pattern name is live, and the load is of 5 kN per meter square. Click on apply, click on OK. Now move to the story number 9, which has a different set from this set. So make sure that you have selected similar stories. Select the shells, then click on assign, shell load, uniform, and click on live and type here 4.5. Click on apply, OK. Then move to the story number 15. Select the shells, click on assign, shell load, uniform, live, and here it is 4. Click on apply, then click on OK. Then again move to the story number 20. Click on assign, shell load, uniform, and make it is 2.5. Click on 8, uniform, click on apply, OK. Now you will see that story number 23. Here will be no walls no construction will be there. So we have to remove the live load from here. So select the shells, click on assign shell load uniform, and delete existing load. Click on apply. Okay, you can see here it is removed. Now we will apply the cladding load. Then move to the story number 1. Then cladding load is applied. Select the outer beam carefully. Now we cannot select here all stories because all set of stories have different outer beams. So we will select according to set of stories. Here it is set of story 1 to 8. Make sure that you have selected similar stories. Select the outer beams one by one. Here you can see 96 frames are selected. Now click on assign frame load distributed and type here 0.2. Then click on apply and OK. You can see load has been placed. Okay, now move to the story number 9. Select the outer beams or frames. There it all. Again click on assign frame load distributed 0.2. Click on apply. OK. Move to the next one. That's all. Click on assign frame load distributed 0.2. Click on apply. Click on OK. Okay. Now move to the next set of story. Select here the outer frames. Click on assign frame load distributed 0.2. Click on apply and OK. Now again we will delete the cladding load from the story number 23. The reason is same as before, there will be no construction over there. So select the outer frames and click on assign frame load distributed. Click on the delete existing load, this one. Click on apply and OK. Now we will move at the base of the story, this one. We will place the joints here. Okay, select the area over here. Click on assign joint. Select joint restraint. This one. Okay. Now we will draw the auto draw clad. So here draw auto draw cladding, use floors option, click on OK. You will see in 3D view that auto cladding has been placed. Now we will define the wind load according to the parameter that has been considered in Bangalore. So first of all we have to define the load pattern. Click on define and load pattern, type it in this wind, select the type here from wind and click on select the auto electron load category IS 875-918-1987. Click on add new load. Now modify the load. Now we will see where the wind speed is 33 in Bangalore according to the code IS 8751987. Parent category as free, structure class is a C, risk coefficient K1 factor is 1, topography K3 factor is 1. Click on OK and then click on OK. Now we will click on this is a plan view. Now we'll define apply the wind load, then click on elevation part here, select here A, apply OK. You will see the section view from A side. Okay, so select here from all stories option, click on all the shells, select all the shells, you can see 41 shells, then click on assign shell load, wind pressure coefficient, wind pattern load is wind, coefficient is here plus 0.8 according to the code. Select here windward side, then click on apply OK. Now again click on elevation part, select B from here, apply OK. All stories option, select this shell part, then again click on assign shell load, wind pressure coefficient, and same as for A, nothing is going to change here. Click on apply, click on OK. Now you can see it from plan view, select any story or story 1. You can see here the left part of the building is applied with the window. Now this part is remaining. So again go to the elevation, select here D and click on apply OK. All stories and apply, select this shell part, this one, and then as click on assign shell load, wind pressure coefficient. Now see here it is of minus 0.25 and the side is leeward side. Okay, click on apply OK. Now select the C part from the elevation, select C from here, click on apply, click on OK, select the shell part over here, then click on assign as before. Wind pressure coefficient the same as for D. Click on apply, click on OK. Now go to the plan view. See here also the load is placed. Now these parts are remaining. So go from elevation, select here one, apply, OK. Select the shell part over here. Now you can select all the other view as click on from the up down menu, that is for 2, that is for 2. Select the shell part, then for 3, because the load is same from all these views. You can see it from the 3D view also. Now click on assign, then shell load, then wind pressure coefficient, and make sure that here it is minus of 0.8 and the direction is leeward side. Click on apply, click on OK. Now you can see it from the plan view where the load is placed. And OK. You can see the loads which we have defined for all the sections. Okay. Now we can analyze our building from analyze option and run analysis. It will take time, so I am leaving this part. And after that we can check the building for design. Here it is concrete frame design. You can click on start design, check. Right now it is disabled because we have not done the analysis. So after the analysis part it will be enabled for you. Then click on start design, check. It will design the building part. Here it is all about. Thank you for seeing this video.